Up to now, we've just been talking about single atoms. Now we're going to start to put them together to make molecules and compounds. I will use those terms interchangeably, but there is a technical difference, and you have a question in your assignment about those. You'll need to look up those two definitions. So we are going to now make chemical bonds. We're now going to start putting atoms together. And there's two basic bonds that we're going to use this semester. One is called the ionic bond. And this is formed between two atoms that have different charges. They will form ions first. Those ions will be unbalanced, not electrically balanced, and they will be drawn together by magnetic forces. You can see some examples in figure 2.7. Or atoms can share electrons as they overlap those valence shells and maximize them, bring them up to that octet rule. You can see some examples of these in figure 2.8. First, let's talk about the ionic bonds, which are formed between these ions. So right now you're probably asking yourself, what is an ion? An ion is an atom that has either gained or lost electrons. If you've lost electrons, we call you a cation. If you've gained electrons, we call you an anion, because you're negative, you're anionic. So what does it mean to gain or lose an electron? For instance, if we were to look at lithium and look it up in the periodic table, we'd see that lithium has an atomic number of 3, hence the 3p+. In its electronically balanced state, it would also have 3 electrons. You can see the first 2 in the first shell and then 1 in the second shell. When it becomes an ion, it loses that 1 in the outer shell and it will become a cation. Now it has 3 positive charges and 2 negative, making it overall a positively charged atom. So that's why it's designated Li+. Conversely, if you look at fluorine, which is F in the periodic table, it has 9 protons, so when it's electronically balanced, it will have 2 electrons in its first shell and 7 in the outer shell. But it will then gain 1, and you notice that then it has 2 in the inner shell still, but now 8 in the outer shell. So if you have 10 electrons, 10 negative charges, and only 9 positive, then you'll be negative. So F- designates this anion. So if I have a positive atom and I have a negative atom, they can form an ionic bond because a positive will attract a negative. And that's all you're doing for ionic bonds. These are like magnets. One positive needs to balance out one negative. If we're covalently bonded, then we're going to share. There's a couple of figures in the book, and then I did a couple of other molecules so you can get the idea. One of these is water, which is H2O. Oxygen has an atomic number of 6. So it'll have also 6 electrons, 2 in the first shell, and it'll have a total of 8. So you can see 4 plus 1 is 6 in that outer shell. So I've broken them up so you can see that these 2 electrons are being shared. So now in the outer shell of oxygen, you have a total of 8 if you include the 2 from the hydrogen. So now it is maximized that outer shell. Remember, the octet rule says the second shell should have 8. Same thing for carbon dioxide. Carbon dioxide has 6 electrons, so it has 2 in the inner and then 4 in the outer. I've broken them up into 2 and 2, but you can see 4 plus 2 is a total of 6. 4 in that outer shell. There's oxygen again. It has 6 in its outer shell, but if it shares 2 with the carbon, you can see this oxygen now has 8. It has maximized that outer shell according to the octet rule. If you look at this oxygen, it has 2, 2, and 4. It has 8. It has also maximized its outer shell. And if you look at carbon, it has 2, 2, 2, and 2, also 8. It has maximized its outer shell. And the outer shell of electrons is a valence shell, hence covalent bonds. Cooperation of the valence shells, covalent. So by sharing electrons, we can also form bonds. So either we will overlap the outer shells, or we will make ourselves into magnets and be drawn to each other. So ionic bonds are magnetic bonds. Covalent bonds are sharing bonds.